In today's lecture, we'll be discussing how a basic SR latch works. Now, what we are going to discuss today is a NAND SR latch, which is otherwise also known as S bar R bar latch. Now, why it is called S bar R bar latch, we will just have a look at it and we'll be able to understand why it is so called. Now, the basic construction of a simple NAND S-bar R-bar latch is a cross-coupled NAND gate configuration. You can see the circuit diagram where output of one of the NAND gate is the input of the other, and similarly the output of this particular NAND gate is presently the input of this particular NAND gate. Now the basic configuration here, the other two inputs are pulled high to +5, that is high logic, using a 1 kilo ohms resistor. So whenever we switch on this particular circuit, the inputs S and R will be pulled up to high voltage, that is +5. Now the output two complementary, that is if one is Q, the other one will be Q bar, and if the output is 0 at Q and 1 at Q bar, this particular state is called reset, and if it is the other way around, that is Q is 1 and Q bar is 0, it is the set state. Now this is true for any type of latch, whether the latch is constructed out of other gates, or it's a gated latch, or it's a JK, or it's D, or it's SR, whatever it is, the output is the same. Now let's see how this particular circuit works. To understand this, we will have to first understand what happens when this particular circuit is under power down condition. That means we have constructed the circuit, but the power is still off and it is at 0 volt. So in this particular situation, the output is definitely 0, and when we try to switch on supply, so whenever we switch on the power supply, the input, that is S and R, will now change to 1 and 1. So in the present input at S and R, we have 1 1, and there may be two situations, that is if the NAND gate #1, if this particular NAND gate responds first, then what will happen? Now let us assume that this particular NAND gate is working first. So the output will be because of what is there at the input. Now one of the input is S and the other input is the other NAND gate's output, which was previously 0. So this particular NAND gate's output will now be 1. So if this is 1, this particular 1 will now be available at the other input of the NAND gate, and by default the other terminal, that is the R, is presently having 1. So 1 and 1, the output will become 0. So this is one of the situation where if the NAND gate 1 responds earlier, or by any chance this particular section performs faster compared to this particular section. Now there may be another case also, and this particular situation, as we know, will be called as set. Now there is another situation which is possible, that is if the NAND gate 2 now responds early to NAND gate 1. So if this happens, the input of the NAND gate 2 is presently having 1 and previously it was having 0. So the output now changes to 1, and this particular 1 is now available at the input of the first NAND gate, and the output will be 0. So you can also see the truth table which has been given here. This is the truth table of the NAND gate, so that this is given here so that we can easily understand how this is functioning. Now, in this particular, if this particular situation takes place, then the output is reset. So, during power up, when you are switching on this particular circuit initially, any one of the output may be possible. Any one of the output will be possible. So in our case, if we want to analyze this particular circuit further, we will assume that any one of the output will assume any one of the outputs. Either will assume output to be reset condition, in the reset condition, or the output to be in the set condition. Now let us analyze the other combinations. So in this particular circuit, we can see that we have considered the output to be 0, 1. So present state is 0, 1. Now output Q is 0, Q bar is 1, and both the terminals are presently open. So due to the pull-up resistance, S and R are at the default state, that is high. Now let us, since this condition is a reset condition, in order to understand the change at the output, we'll have to set this particular circuit. So using the set terminal, that is the S, or the R terminal, we'll have to somehow change the output. So in order to do that, what we will do is we will use the set terminal and connect that to ground. So when we connect this to the ground terminal, this particular terminal momentarily now becomes 0. Now, since we have made a change in NAND gate 1, so this is going to work earlier compared to NAND gate 2. Now here, the high logic got changed to 0 because of this particular switch. So at the input of this NAND gate 1, we have 0 and 1. So the output will be 1. So this 1 gets reflected here, and this 1 now will be available at the input of the NAND gate 2, and this 2 1 will make this output 0, and hence what we get at the output is set. Now initially I've just mentioned that this particular circuit is sometimes called S bar R bar latch. Now this is because when we are connecting the S terminal to the ground, only then that particular section is getting activated. That is, when we are using the set terminal, the output is getting set irrespective of the previous state. Irrespective of the previous state. So whenever we are subjecting the set input terminal to low logic, only then that particular section output is getting activated. So we can call that the latch is active low. That is, when the inputs are connected to low, only that particular terminal gets only because of that particular terminal the output changes. Similarly, now if we move on to the next section where the previous state was 1 0, it is now the present state. Now the output 1 and 0 are available, and this particular output is fed back to the respective NAND gates. Now what we will do is we will see if we restore the switch S to 1 again, what happens to the output. Now let us move the switch. Once we move the switch, the 0, the low logic is removed, and again due to the pull-up resistor the input changes to 1. But let's see whether the output changes or not. Now since again the NAND gate 1 is getting activated, this NAND gate 1 gets activated, so the output will be changed here first. So let us see what happens. The output 1 remains 1, and this 1 is present here, 1 and 1, it will keep this output 0. So as we can see, there is no change even when we change the switch from 0 to high. So this is called no change state or called the latch state. So whenever you return back to the state 1 1 at the input, it is the latch condition. Whenever you make any changes to S and R, only then the output will respond, else it will be in the latched state. Now let's move on to the next section where we will be resetting the S bar R bar latch. Now to do that, let us connect the R to the ground. When we connect the reset terminal to the ground, previously available 1 now changes to 0, and this NAND gate will respond now. So the 0 at the output will now change to 1, and this 1 will be available at the input of the NAND gate 1. So 1 and 1 at the input of the NAND gate 1 will trigger the output from 1 to 0. So what we can see is once the reset terminal is activated, irrespective of the state of the previous state, present state, the next state will become reset. So whenever we use the reset terminal or activate the reset input terminal, the output of the NAND latch becomes reset irrespective of the previous state. Now let us again see what happens if we remove this particular switch and get it back to 1. So when we remove the switch from low to high, again this particular NAND gate is getting activated first. So the output will be, it was 1. Since the input is 0 1, the output remains 1. This particular 1 is available here at the input of the first NAND gate. So again both the ones will make the output 0, and hence we can see that the next state is same as the previous state. So the condition is the no change or the latched condition. Now let us see the last combination where we are going to simultaneously use both the inputs and connect it to the ground. So when we connect both the switches simultaneously to the ground, what happens is previously input was 1 1 and now it has gone to 0. It has gone to 0 at the input simultaneously. So whenever one of the NAND gate input is 0, the output will be 1. As it is evident from the truth table of the NAND gate, we can see whenever there is a 0 at any one of the input, the output is 1, else it is 0. That is, when both the inputs are high, the output will be 0. So in this case, when we are simultaneously connecting both the inputs, that is the set input terminal and the reset input terminal to 0, the output of the NAND gate, irrespective of the previous output, the output will now become 1 1. And since one of the output is Q and the other output is Q bar, and both the outputs are same here, so this particular state is an unwanted state and it is a not used state. So this is how a simple NAND SR latch functions, and this is the basic building block of any memory element. I hope you have understood the basics of NAND SR latch, and thank you very much for watching this video.